Hi, everyone. So I hope you guys are motivated after that fantastic opportunity. There's so many places that you can work because every single place has data. So the DoD is one of them. All right, cool. So let's get started. Today we're gonna be talking about cars. So let me know in the chat if you have a favorite car, type of car, just like an icebreaker. My answer is like a girl answer because my favorite type of car is a red car. I don't know much about cars. I see in the chat Toyota, Charger, Broncos, Jeep. Oh, I love Jeeps. I'm gonna change my answer to a Jeep. A pink Jeep. I want a big pink Jeep. Awesome. All right. So, a little bit of housekeeping. Where are we? So, we are on week 3. It's Thursday, so it's gonna be the second lecture. So it's gonna be this one about interpreting tables and charts. So just like click on it and open it so you can follow along. Um, Good news or bad news, I don't know. Depends if you're been loving Excel. We're not really gonna be doing Excel today. We're gonna be practicing our data literacy skills. So if you were not liking Excel is good news, but if you were loving Excel is bad news. So you don't need to open Excel, just the case is enough. And as always, if you have any questions say, or comments, the chat I'm going to be monitoring is the live chat. If you have a specific, maybe it's not going to happen today, but if you have like a specific technical question or somewhere that you got stuck, then you have hashtag extra help where the TAs can help you as well. Um, all right, cool. So, what is the case for today? The title is Which car makes and models are the most popular in the US? So, the goal for today is to learn how to interpret tables, bar charts, and pie charts. So, we're going to revisit those things that we learned in the first lecture on how to become data literate. So, we were saying, okay, to be able to read, to be able to be fluent in data, we need to know how to read data, how to write data, how to think data, and how to translate data. So today we are going to be practicing reading, thinking, and a little bit of translating. So specifically tables, bar charts, and pie charts. And we're going to be talking about frequency as well. So, what is the business context? You today work as an analyst at a small car dealership. The dealership is planning to expand its marketing campaigns to give better coverage to car makes and models that have proven to be more popular with consumers. Um, so the business problem, so that's the context. Basically, you work as a data analyst for a car dealership. The specific problem is that you have to write a report that summarizes car sales data in the United States. And for today, specifically, we're going to be working with some data from 2020. It could have been data from this year, it could have been data from last year, but the data that we have today is from 2020. But the the steps are going to be the same whether you had data from today or a few years ago. Um, so the your boss is going to use this report to make decisions about what makes and models to promote via advertising. So basically, you just have to do a report on what are the most popular cars. And then for the analytical context, this is usually where we give you the data. You don't have to actively do something right now, but if you are curious, we're getting this data from this article that was posted on Forbes. So here they have all the different kinds of cars and how many cars were sold, etc. So, um, yeah, this is real data. So we're going to be working with this real data. Um, all right, cool. So let's start with the table, how to read a table. So we already got familiarized with tables, so I'm sure everyone is gonna breeze through the content that I'm gonna show right now. But as a refresher, tables have two components. They have rows and columns. And while you have free will and you can do whatever you want with tables, typically, if you're working with data in a data context, you will want rows to represent the object that you're studying. So, for example, in this case, that we're working with cars, each row represents a car. If you were working with a database full of people, each row would represent a person. If you were working with items at a store, each row should be an item. And then the columns are the characteristics of those objects of our study. So for cars, maybe you will have characteristics of a car. So how many horsepowers does it have? What's the mile range? What's the price? What's the color? Different characteristics. So here on the screen, we are seeing a table with people, their first name, last name, and favorite food. And yeah, I agree with Jennifer. Who likes broccoli? Well, I like broccoli, but I wouldn't say it's my favorite food. um, all right, so we have this table. And just exactly what I was saying earlier, in here, this table, it seems like the object of our study are people. So each row represents a single person. You don't have the information for two people in one row. Each row belongs to one of the objects that we're studying. In this case, is people. Um, and then each one of the boxes are cells. So hence why Excel is called Excel, because it's cell. So you're working with many cells. So to read a table, you usually start by locating the row that you're interested in. So the person, in this case, the person that you're interested in, and then you find the characteristic that you're searching for. So here, let's do it real quick. What is the first name of the person whose last name is Fisher? Yes, exactly. It is Sean. And why? Well, they told you we want Fisher, so you search for the last name column. So you have the last name column. Then you find Fisher, and you want to know the first name of that person. So you get the answer, which is John. So perfect. Now, next exercise. What is Anna Stevens' favorite food? Yes, exactly. It is pasta. So Anna could be me because I love pasta. So how does it work? Well, they told you it's Anna Stevens. So in the rows, you find Anna Stevens. Here we only have favorite food, but we could have age, city, job, a title, company, favorite type of car. You could have a lot of characteristics. And then once you have located Anna, you find the attribute that you're searching for. In this case, favorite food, we determine her favorite food is pasta. Um, all right, so that was just practicing how to read data. We are masters in reading tables by now. So let's talk about different kinds of tables. So as you may know by now, tables are extremely useful to represent virtually any kind of data. So you can put a person's medical record in a hospital database. You can list all your Facebook friends in an Excel file. I've seen people listing all their monthly expenses. I've seen people listing their favorite or the movies that they have watched and the rating that they gave to each movie. Um, the possibilities are endless. So you can do so much with data. But there's a very specific type of data that you, as a data analyst, I should say, a specific type of table that you as a data analyst are going to be working with quite a lot. And these tables are called frequency tables. So frequently used frequency tables. Hey, it was a pun. Um, so these are tables that list how often an element appears in a data set. In other words, the frequency of that element in the data set, hence the name frequency tables. Um, so here we have the cars sales from the article that I showed you earlier today. So we have each row is an element, so the cars, and then we have the columns, so the different characteristics of the cars. So here, now I ask, can you say why this is a frequency table and share your thoughts with the class? So let's see it in the chat. Do you think this is a frequency table? And if so, why? All right. So keep those answers coming in. But yes, so it is a frequency table. It is valid. I saw someone saying, like, I'm not sure it is. It is valid that you're questioning it. That's the point of these questions. But why is it a frequency table? So the first giveaway is that we have a column with numbers. If everything was just letters, so for example, let's go back here. This one is definitely not a frequency table because there's no numbers, so can't be a frequency table. This one has numbers, so we're on the right path, but just because it has numbers, it doesn't mean that it's a frequency table. But in this case, it is because it's counting how many of something there are, how often something happens. So in this case, yes, it is a frequency table because it says how many Ford F-Series do you have? How many Chevrolet Silverados do you have? And so on. So let's go with the next exercise. Let me show you the table so you see it. And now looking at this table, tell me what was the model with the highest sales? And the second question, how many Honda Civic units were sold? While I see most people having the correct answer, I've seen a few answers that are not correct. And that's okay because it's meant to be a little bit tricky, the question, but maybe have a second look at the question. All right, so let's go with those answers. So what was the model with the highest sales? The first thing that you need to check is that your data is sorted, because it could be that these numbers are not in order and you might be tempted to answer the first row, but they're not always organized. So that's one thing to pay attention to. In this case, it is. So if you didn't pay attention and you answered this because it was the first row, it's your lucky day. But in general, you should make sure that it is sorted so you have the actual answer. So the answer is the question, if you read it carefully, it says, what was the model? So the model is F series. It's fine if you say Ford F series because you're just being extra explicit. But I saw a few answers here and there of people that said just Ford. And if you notice, the make could be repeated. Maybe here you could have something that says Ford Fiesta and like the respective number. So saying Ford is wrong because first of all, it's asking for the model. And second of all, the make is not unique. I mean, in this data set, Ford F series happens to be the only Ford, but you could have more. So something to pay attention. Now let's go with the second question. So the second question is, how many Honda Civic units were sold? And this was another tricky question because you might be tempted to see Honda, and answer this. But it was not any kind of Honda. It was the Honda Civic. So the Honda Civic is this. So these are just things that as a data analyst, you have to always be paying a lot of attention because your task is to speak fluently the language of data. So you have to pay attention to those things. So that's okay if you maybe get it wrong because we're here in class, but this is also that you acquire with experience and with practice. When I first started my first jobs in data, I would make so many mistakes. And after maybe I got scolded from my boss or something funny happened, I learned to be like super attentive to everything. So don't worry if it doesn't come at first, but keep in mind and start practicing that muscle to start paying attention to detail. But yeah, thank you for participating, everyone. Let's go with the next one, which is bar charts. So let's talk about bar charts. So the car sales frequency table can also be represented graphically because we have this table here, which is fine if you need the exact numbers. Like if your boss told you, hey, I need to know the exact number of Ford Fiestas in my data set so I can buy this specific item for that type of car. Then you would need the exact number. So a table is the best representation of your data. But remember that your task today is to give information to your boss to create a marketing campaign. So for a marketing campaign, do you really care if you have 367,387 cars of this make and model, or if it's 367,388? Probably doesn't make difference to the numbers, to like the exact numbers. In that case, maybe it's better to use a bar chart because you just want to get the big picture of what's going on. So the bar chart would be better in that sense. So different ways to represent the same data. So let's see how it would look like. So this table that we were just looking at, we have it here. So notice it's exactly the same one. Ford F series, here we have the same number, everything is the same. But something that maybe, unless you're a math prodigy, something that maybe you didn't notice right away is the proportion between items. Because here the number, you can't really picture a number, but here the bar, you can quickly see how many more cars of one kind you have versus the other one. So here we have the bars. So let's discuss each one of the components of the bar chart. So the very first thing And this is something that you should always give to all your charts, not just bar charts, but all your charts, is a title. So people know what they're looking at. Even if you're not in the room to explain your visualization, they are able to look at the chart and say, okay, I know what it is. I know what this chart is telling me. So here in this case, the title is explicit, it's clear, so it accomplishes the goal of a title. So you have sales of cars between January and June 2020, the top 10 models. So that's the title. Um, then you also have the titles for the axis. So this one right here is the x-axis. This one is the x-axis. And this one is the y-axis. So x-axis and y-axis. So here, this is the title for the x-axis. This is good practice, just so you know what do you have in your x-axis. So in this case, we have the different make and models of cars. And then here you have the title for the y-axis. If in the y-axis you have a number, you should say what that number is. So in this case, that number is units sold. It could be, for example, if it was money, you should say in dollars, in euros. If it's in numbers, but maybe it's in millions, whatever it is, you clarify that in there in the y-axis title. In this case, the number it is what it is, so it's just units, units of cars that were sold. Um, Yes, so it will always be the x-axis is always the one at the bottom, and the y-axis is the one standing. So that's never gonna change. But good question. All right, so we have the y-axis, the x-axis. We already talked about this. We also have the tick labels on each axis. So those are the names for each one of the things in the axis. So for example, here we have the tick label for this one, this one. So all of these legends are just the tick labels. Because if you didn't have this at all, you wouldn't know what you would just see a bar with a number, but you wouldn't know what it is. But you need the tick label to know what it is. Also, something regarding the design that they did well in this chart is that instead of writing the name completely horizontally, they made it a little bit diagonal. And this is always a good strategy when you have labels that are very long. Because if you had written, for example, Chevrolet Silverado, which is pretty long, if you had just written it horizontally, it would be like written over the text of the other bars. So this was nice that they did that, so it's clear to read. So when you're doing your dashboards later on, make sure that everything is legible, everything is clear, and you're able to read it. Then on the y-axis, we have the ticks for the tick labels for the numbers. So every jump is 50,000, 50,000, 50,000. And this is also good practice because you see the jumps are constant. You're not jumping from 50,000 to 100,000 and then suddenly to a 1 million or something. So the distance makes sense. You're not being deceiving. Um, let's see. I'm checking answers in the chat. Um, what about a model with an z-axis? So yes, you could have a third axis and make it 3D. I find it a little bit hard to comprehend 3D visualizations for bar charts. So typically they're not there that often, but for some other visualizations, yes, you will have that z-axis. Let's see the other question in the chat. Could they have made this graph to where the model is on the y-axis and the units sold on the x-axis? Absolutely, yes. You could have had someone do something like this. Let me pull my drawing skills, but yeah, you could have had something like this. And this, let's say, is the F series, and this one is the Silverado, and this one is the Ram. And here you have the numbers like 200,000 and 300,000 and so on. So yeah, you can flip it. And the decision, that one is almost a decision completely up to you because it's mainly based on choice, on what looks better. Again, if the labels here are very long, I would switch to this option so you can clearly read this label here because it would never like overstep on the other one. But it's completely up to you as the data analyst to make that choice to decide what you want. Um, is there a relation with Tesla, a Model X, and Model Y? I don't know, actually. I'm gonna Google that after this call. Um, Another question. Do you find that some companies have standards for the charts being used? Um, Depends on the company. Some companies, most companies, I would say, would like to keep the same style of colors and branding. So maybe if their logo is purple, they tend to draw everything in purple. And maybe they use a specific type of font, and you would use that font so it's like consistent with the branding of the company, and they would just tell you what it is. And but if they don't tell you anything, then that's fine. You make your own choice. Um, how do you choose the jumps? That would depend on your data and how much granularity of your data you want to display. So that's also something that you can make the call for it. A lot of times the call is going to be based on the question that you're trying to answer, the business question. So for example, if you wanted exactly the number of units, maybe you would do a one by one. But since it's a marketing campaign and we just want to get a general idea, every 50,000 was fine. All right, cool. Awesome. What else do we have? So here you might have noticed the bar chart has bar labels as well. So we have the exact number here. In my opinion, for this specific case, if I had been the data scientist or data analyst behind this chart, I would have not put these numbers in here. Why? Because I think it's too much information. And especially since it's a marketing campaign, we want a ballpark of the number of cars, not the exact number. But on the other hand, if your boss was like, hey, I need to know the number of cars in the parking lot to get accessories for each one of them, then I will put the label. So this is something that you get to make the choice as well. Um, yeah, so it's completely up to you. Up to you and also up to the situation. So you make that decision. The other cool thing that you don't always have to have, but that we have in this case, is the grid. So the grid are these gray lines here. I don't know if you guys are able to see them. But these grid lines are associated with these labels here, the number labels. So you know that each jump is like 50,000 units. So for example, this one you would say, okay, it's like two jumps, two floors, two levels. So this one is like approximately a little bit more than 100,000 units, which it is 124,000 units. So even if you didn't have the numbers here exactly, just by having the grid, um, it helps you to see more easily how many do you have. Um, let's see, questions in the chat. So for the numbers here, it's completely up to you. You can keep them, you can not have them. It's your choice as the data analyst to have them or not. Me, in this case, I would have not included them just because it's a marketing campaign. I don't think they want the exact number. But depending on the situation, maybe you do want to include them. Um, all right. I like the fun fact about the Tesla. We learn all kinds of things in this program. All right, cool. Time for the next exercise. So one of the main advantages of a bar chart is that they allow you to quickly compare different bars without having to look at the actual numbers. So I'm gonna remove the numbers now and actually no numbers in the y-axis. And just by looking at the grid, don't look at the numbers in the previous plots, just look at this plot that I'm showing you here. I removed the numbers. Pick two models so that one of the models that you picked has approximately twice of the number of units as the other one. So for example, you would say model A has approximately twice the sales of model B. So I'll give you, let's say, 2 minutes for that, and then we'll read some answers.
2 minutes left. Left. Seconds left. Seconds left. 5, 4, 3, 2, 1. Time's up.
All right. Thank you so much for those answers. I'm going to pick one answer at random. Hopefully it's right. So I see Silverado and Civic. So let's look at Silverado, which is this one, and Civic, which is this one. So let's see how I would approach this. So I see this one has 1, 2, and a little bit. So 1.3 in height. And then, no, 2.3, 2.3, 2.3. Actually, this is like half, right? 2.5. And this one has 1, 2, 3, 4, 5, approximately 5. Yeah, so that's a good pair. So Silverado has approximately twice the sales of Civic. So great job, Kasi. I was reading Kasi's answer. Let me read another one. Ram pickup and Toyota Camry. So Ram pickup is this one and Toyota Camry. So I'm looking at the grid because I know that the grid, especially that they seem to be drawn at a consistent space. They have a consistent space between each other. So I assume that these represent the same quantities. So that's what I'm looking at. So the Toyota Camry has 1, 2, and a little bit. That also looks like approximately 2.5 in height. And this one has 1, 2, 3, 4, 5, approximately 5. So yeah, this one was also correct. So that was Giovanni's answer. And from what I was seeing, yeah, you guys Got it. Right. And notice that the question is approximately, approximately. So it's fine if it's not exactly half. Um, so so people have the timer in their head. Many years, like 20 years from now, you're gonna listen to that timer and you're gonna be like, Amazon Data Analytics course. Some training here. It's like training your pet, but instead I'm training you guys. All right, so here are some of the answers, possible answers. Maybe there were more. So F-Series and the Toyota RAV4 or RAV4. I don't know how you say that. Silverado and Civic, Ram pickup and Chevrolet Equinox. So there you go. You guys are so funny. In the middle of the night, the timer. All right. Awesome. Let's do exercise number 4. So we have added the tick labels back. The numbers are back. Uh, do you see, could you do the exercise again? Do you see, is this chart okay? Do you see anything wrong with this chart? So let's see some of those answers.
2 minutes left. Left. Seconds left. Seconds left. 5, 4, 3, 2, 1. Time's up.
All right. So I am so proud of all the answers. Everyone caught on right away. The issue is that it doesn't start at 0. So what happens then? If you try to compare values, if you do the same method that we were doing before, for example, this one seems to be half the size of this one, but you can't really make that statement because you are not starting from 0. It also makes seem, for example, the Sierra super tiny, very small, but it's 100,000 units. That's not small, but this is deceiving. What else? I saw another good comment. I forgot what it was. The Ford marketing. This was made by the Ford marketing team. I like your comment, Caddy. Approved by Ford. Yeah. So you gotta be very, very careful with this because otherwise this would be deceiving. I found another really good example on the internet of why you should always, most of the time, start charts at 0. Because look at this one with height. What would happen with height if you start not at 0, but you start basically at 5 feet? So Taylor Swift is 5 foot and 10. And then Sabrina Carpenter, she's only like a little bit, like 5 feet almost, yeah. And Ariana Grande is like 5'1", and so on. But like, if you see them in person, Sabrina Carpenter is not gonna be like a minion next to Taylor Swift. And the reason why is because the height is incorrectly, like it should have started in 0. So a normal chart would look like this. So this one starts here at 0. They didn't draw the number, but it starts in 0. So yeah, Taylor Swift is 5'10", but then you have, I don't know who any of these people are, but you have this lady that is 5 foot. So this is the same height as Sabrina Carpenter. So Sabrina Carpenter would be here, which is more reasonable. Like she wouldn't be the size of Taylor Swift's high heel. Yeah, I know Iron Man, but not the other ones. Yeah, so now I hopefully you will never forget to always start your plots at 0, unless you have a very, very compelling reason not to. So the only compelling reason I can think of, and if anybody else can think of a different reason, please share it in the chat, would be, for example, if you're looking into details. But the way I would put it in, would frame it as, would be the following one. So for example, let's say you want to know how many dog owners we have in the group versus how many cat owners we have in the group. And then you have a bar like this. And then here it says like, I don't know, 50. So this is very hard to know, like what is the actual difference, right? Because they're very similar in height. So what I've done in the past in a situation like this is that I create, I mean, this is hard to draw by hand, but bear with me. I would draw like a zoom here. And then here I will have the new bar chart starting at 50, and then here like 55, and then here and here. And here I will put a legend like, notice that it starts at 50. Or even if I was just doing this one, I would put the notice, like some label saying like, hey, this does not start at 0, so I'm not deceiving with my visualizations. Oh, I love that we're getting some dogs in the chat. This was the best thing ever. Oh, that's awesome. But yeah. So let's see, what do we have? Yeah, so very, very important. Always start your bar chart at 0 unless you have a really good reason not to. Yay, we're getting some cats in the chat now. I love this. All right, cool. Last question before the break. So bar charts and frequency tables can both show counts for your variables, true or false. And let's do 1 minute for that one. All right, I had it only to be 30 seconds since I saw that everyone got it right. Yes, so bar charts and frequency tables can show counts for your variable. So for the frequency table is more obvious because you have the count here, but for the bar chart, you can also include the numbers in here, like this one. You can have the numbers in here. All right, it's a fantastic job so far, everyone. We are making good progress today. So today we can actually have the 10-minute break. So after the break, we'll talk about pie charts. And I absolutely love seeing your pets. So if you want to put a picture of your pet while we go on the break, that would be fantastic. Yeah, so I'll give it back to Basil and I'll see you guys in 10 minutes. All right, welcome back, everyone. So let me share that screen. I gotta say, today is one of my favorite lectures ever because I love seeing all your pets in the chat. Makes me wish I had a pet so I could share my pet picture with you guys, but I'm living through you all, seeing all these pictures. All right, cool. So let's come back. What are we doing today? So today we're data analysts for a car dealership. Our boss came and told us, hey, you gotta do a report so we know what are the most popular cars in the US so we can do a marketing campaign. So that's what we are doing right now. Yeah, so awesome. Um, So before the break, we were practicing our data fluency by doing a deep dive on how to read a table, doing a deep dive on how to read a bar chart. And we were also practicing a little bit of the writing aspect of it because we were discussing design choices. We were saying, why we should include zero in the x-axis, why we should discuss the label, put the title, give the source to the data set, all these different things. Um, so now let's talk about pie charts. So pie charts are another way to represent data. It's very popular. I'm not a huge fan of the pie chart because they can get very messy very quickly, but they're important to study. So let's deep dive on those. So pie charts are good to represent data, but also they're very good to represent the frequencies of data, especially the relative frequencies as opposed to the absolute frequencies. So let's stop for a second and talk about absolute frequency and relative frequency in case this is the first time you're hearing these terms. So we have absolute frequency. So absolute frequency tells you how many. So the question is how many. So for example, if I looked in the chat, I could say, and I'm gonna make up a number, but it could be a real number. I could say there's 50 dog owners and there's 50, no, let's say 48 cat owners and 2 rabbit owners. So that's absolute frequency. I'm just saying the numbers, how they are. But then you could have relative frequency. So the relative frequency tells you how often compared to the total. So the total here would be 100. That means that 50% of the people are dog owners. And you can represent this relative frequency as a percentage, so 50%. You can represent it as a fraction, so 50 over the total number, so 50 over 100. Maybe you can simplify the fraction to 5 over 10, which is 1 over 2. And you could also represent it as a decimal, so you could say 0.5. So the relative frequency is just to know how often does that specific case happen. The absolute frequency is just how many you care about the actual number. So yes, in the pie chart, you can have both. You can have a relative frequency and an absolute frequency. But since the circle represents 100%, it represents everything. You would never, so here's one tip about pie charts. You would never have a pie chart that represents 200% or that represents 50%. The whole circle has to represent the whole. It's 100%. So this is wrong. This is wrong. So that's why it makes it so easy to represent absolute relative frequencies, because if you have a slice that is like this, you can quickly say, okay, that's 1/4 of the data, or that's 25%, or however you want to represent it. But it makes pie charts very attractive to to relative frequencies. It's very easy to represent relative frequencies there. Let me check the questions in the chat. Uh, does relative have to be compared to the total, or can it be compared to other data? Yes, you're comparing to the total. So you would get the total and compare to that. And then you can use those percentages to create your own conclusions. Like, yeah, 48% of the people in the group like cats, 50% of the group likes dogs, and you can compare those two numbers. But to obtain the actual percentage or the fraction or the decimal, you have to use the total. That's a funny one. There's a funny pie chart in the chat. Let's see if I missed a question in the chat. No, I think that's it. So let's keep talking about pie charts. So for instance, in our table, let's look at our table. This is our table. If you add all these numbers, you will get this number. So in total, for this table, we have 1,792,146 cars. So the pie chart represents all those units, 100% of them. And this is a flaw people make sometimes, where the pie chart doesn't add up to 100%. They're like, oh yeah, this is 50% and this is 30% and this is 40%, and like this doesn't add up to 100%. If someone in a job interview, they're doing a dashboard and they do something like that, I'm like, not hired right away. It has to add up to 100, or the other way, like 50% and I don't know, like 40% and here 2%, and it doesn't add up all the way to 100%. It always has to add up to 100%, because that's the power of the pie chart, that you can quickly see what is the relative frequency. But if it's not 100%, then you can't make those assumptions. So it has to be 100%. Yeah, so the pie chart is always 100%. Yeah. So the let's see with an example. So for example, the Ford F series is this much. So this slice represent the Ford series. So again, when we have the number, the actual number here, that's the absolute frequency. When you have the how many. And then if you want to know how does it compare, you would have the relative frequency. So to compute the relative frequency, we see it here. It was given to us. It's 20.5%. But how do you compute that number? You just divide the two numbers for between each other. So 367,387 divided by 1,792,146. So that's the fraction representation of it. If you get a calculator and you divide these two numbers, you will get 0.205. Let me write this bigger, 0.205, which is approximately the same as 20.5%. So that's where that 25% comes from. So again, for the F series, the number itself, how many cars that were F series we had, this is the absolute frequency. And if we look at the percentage, which is 20.5%, that's the relative frequency. That's like how does it compare to the rest, to everything? So we had 20% of the data is F series. Yeah, so we have that. And I like the meme that Juan sent in the chat because yes, it's called a pie chart because it resembles a pie, like an actual pie that you would eat. So that's where the name comes from. If you round numbers, it can definitely, that's a good question. So the question in the chat is, what happens if you round numbers? Can that throw off the percents? It can. So I would just, if you're visualizing something, I would just make sure that my rounding checks such that it adds up to 100%. So it doesn't seem like you have something wrong in there. All right, so that's how it is. So in this case, you could do a pie chart like this just to highlight something. So here we're highlighting Ford F-Series. So now I'm starting to begin that this marketing campaign is actually financed by the Ford people because we keep talking about Ford. But yeah, anyway, so all the other ones are clustered together here and we are highlighting here by the Ford. So this is sponsored by Ford. Yeah, so a few things about this pie chart. I would, if I had been the data analyst that created this pie chart, I would make sure that the numbers are more legible. Or I don't know if maybe it's my screen, but for example, for me, it's really hard to see this number, like black against dark blue. So I always make sure that those numbers are legible. And maybe I will make them a little bit bigger, just since we're in the topic of writing data. Yeah, so we have this. Oh, and this right here, it's called a legend. You have to have a legend for the pie chart because otherwise, imagine if we didn't have this in here. Imagine if it was like this. We would be like, yeah, 20% of something, but of what? You wouldn't know what it is. So you do need the legend to indicate what each one of the colors mean. So question number 2. So time for another question. So here we have a pie chart equivalent of or bar chart from before. And the question is, if you compare it to the bar chart that we were working before the break, do you find it easier to read or more difficult to read? There's no right or wrong answer here because it's an opinion question. So let me know, do you think it's easier or more difficult and why? So let's have 2 minutes for that. Oh, wow, what happened to the timer? Oh no, I don't know what's happening to the timer. Sounding funny. Okay, we don't have a timer. Pretend there's music playing in the background. So I see most people saying more difficult. Some people are saying that is easier to see, like beauty's in the eye of the beholder. Some people find it easier to read. Some people find the bar chart easier to read. I'd like to hear from the people that said that the pie chart was easier, why they thought that. Oh, okay, I see. Thank you. I asked it and I got it. So as you guys can see in the chat, there's different opinions. So that's one thing to keep in mind as a data analyst, especially when you're working with visualizations. For some things, there's no right or wrong answer. It doesn't mean that you're doing something wrong. It's choice of design. So maybe if you want to make sure that your message is getting across, what you could do is ask your audience, is this chart clear? Would you like me to do this chart differently? Especially if you're presenting to stakeholders or your manager, you can just ask like, hey, would you prefer a bar chart or a pie chart? But for example, some of the reasons why people are saying it's more difficult. They're saying that there's too many colors, too many numbers, too much information going on at the same time. Um, so it's also harder to compare these slices. Where with the bar chart, it's pretty straightforward to compare these slices. But on the other hand, some people are saying that it's easier because it shows the relative frequency in an easier way, and they like the colors. So yeah, there's gonna be different opinions. So I like this exercise a lot because we can see that in the chat, especially because we're a big group, so we definitely see all kinds of opinions. If you asked my opinion, I would say it's harder for me to read. Um, especially, and we're going to talk more about this once we're working with dashboarding. But you should only use color when the color shows some type of meaning. So, for example, one that everyone here in the United States is familiar with is with election times and maps. So, Democrat states are blue, Republican states are red, and the color has a meaning. So, if New York is colored blue, is because it's Democrat. So, it's not a random choice of color. Oh, New York is pink because it's pretty. No, that color has a meaning. Here, the color doesn't really have a meaning attached to each one of the cars. So it adds more information. You should use color as a way to convey information, but here is just adding cognitive load. So the way I would personally do it, and I think it would be easier on the eye, will be to do different shades of blue. So or like one color, so darker blue, lighter blue. So you don't have a festival of colors going on. But it's completely fair if you disagree with me. No problem. No hard feelings. It's up to the data analyst to make that choice. Um, Also, in general, it's recommended to not have more than 4 slices because then the smaller slices get really hard to compare. But there are ways to fix that. So, for example, you could have this. So you show the top cars, which is Ford, F-Series, Silverado, and the Ram pickup. And then you cluster all the other ones into others. So this one, for example, to me, it conveys much more valuable information because I can see, okay, 50%, approximately 50% of my data is from the top 3 cars and all the other cars are the rest. So for example, if I wanted to focus in half of my market, from this pie chart, I can quickly see that I would only need to focus on my top 3 cars. So yeah, this is one advantage of doing it this way. So typically it's recommended to not have that many slices, just to reduce the amount of slices. Let me check the chat, see if there's any questions. Um, would it be okay to use different types of charts for different types of learners? Absolutely, yes. That's a really good question. And that's part of the skill of translating data to become data fluent, is knowing your audience. You got to know your audience and how your audience likes data to be presented at. So, for example, your boss might like things in a different way than your colleagues or than clients. You should also consider the technical level of the person. So maybe a more complex chart is fine for someone that is as technical as you. But if you're talking to a business person that maybe they're very smart and knowledgeable in the business area, but they're not super technical, You gotta make it easier. You should also some things that we haven't discussed yet, but we're gonna be discussing once we're designing dashboards, making sure that the dashboard is accessible. So, for example, taking into consideration color blindness, so picking colors that are friendly with colorblind people. Um, eh, if something as funny as like if you're working in Miami and your clients speak Spanish, make the dashboard in Spanish, stuff like that. So yeah, that's a really good question. You should definitely cater to your audience. Um, let's see what else. Would it be acceptable to mix the different charts in a presentation? Absolutely, yes. We're actually going to be doing that. I don't know if you remember from the first lecture where we were looking at dashboards and we had a map and a bar chart and some tables. So not only is it okay, you're expected to put it all together in a single dashboard. So we are going to be doing that. Uh, all right, awesome. So let's continue with the next exercise. So this is a pie chart of total sales by car make. Um, let's now, the question is, try to estimate the relative frequency, so the percentages of each one of these slices. So you can make approximations. You don't need to look at the numbers, just look at an approximation. And let me find some timers. Hmm, I think it's just my computer acting up. So pretend there's music in the background. And let's give it 2 minutes for this activity. One more minute. A few more seconds, but I agree with that comment I saw in the chat. You guys are very good at estimating percentages. And all right, so let me do it. This is how I would approach this question. Let's see if my approach works. So I would say, okay, this seems like half, give it or take. So this is like approximately 50%, and this one is approximately 50%. And these two seem to be almost the same size, and they're kind of close to 25%, but we have this yellow slice to account for. So I would say this one is 20%, this one is 20%, this one is 10%, so I have my 50%. And then this one seems like definitely more than 25%. So maybe I would say 32% and 18%. And then I do the sanity check to make sure that it adds up to 100%. That's the whole reason why we're doing this, so we can see the relative frequency. It always has to add up to 100%. So here we have 50, and here we have 50 as well, 100%. So it works. Now I'm gonna look at the colors. So others is 32%. The Honda, I said 18%. Yellow is GMC, so 10%, and 20 and 20. So those are my answers. So let's see the actual result. So the actual result is 37% for others, 15% for the Honda, 6% for GMC, and 20 and 22. So I was not that far off. Yeah, so that was my thinking process. I'd be curious to see if someone had a different thinking process. But yeah, hopefully that helps. I see another question in the chat, which is there anything that can help with the color, selecting colors that are friendly for color blindness? Yes, so once we're working with dashboarding, tools like Tableau, Power BI, Looker Studio, they have color palettes that are colorblind friendly. You could also just look it up what colors are colorblind friendly. And if you know someone that is colorblind, you can ask them, hey, can you see this correctly? Because also there's different kinds of color blindness. So yeah, gotta check all your bases. I see someone forgot to make it equal to 100%. Yeah, that's a big component of it. I saw also another chart. Oh, so that was pretty much it for bar charts. For pie charts, I saw a comment on bar charts that I really liked. So that's why I'm going back to this, which was here when we were talking about the starting at 100 instead of a 0. The example I gave was like a zoom, and I said, I can't really think of another example of a scenario where it would actually make sense to not start in 0, and that could happen. And what is a valid scenario to not start at 0? And then I saw in the chat, Rob mentioned a really good example. And this shows that I'm not American because I didn't think of it. I am American now, but I was not born in the US, which is temperature. Because if you're working in Fahrenheit, the temperature, let's see. So if here, look, if you have it in Celsius, it's starting in -20. Freezing point is 0, which in Fahrenheit is 32. So for example, if you wanted to be very explicit about the weather when it's below freezing, you could put something like this. So this would be in Fahrenheit. Here, it will be 32. And you could put a label here that says freezing point. And that's a very valid use case where you wouldn't necessarily have to start at 0 because you want to denote freezing temperatures throughout the years. So it would be easy to say, I don't know, January here, then February would be down here. So it makes more sense to have the main x-axis start at 32. So that was a really good example, and I'm gonna keep using it for future cohorts. So thank you, Rob, for that one. Where if you were working with Celsius, maybe with Celsius, it does make sense to start at 0. And this shows how Fahrenheit is tricky as well, because then it's hard to compare. Like 64 Fahrenheit is not twice as much as 32 Fahrenheit temperature wise. So it's not a very good scale for temperature, but that's the scale that we use here in the United States. So that was a really good example. So thank you, Rob, for that one. All right, cool. So time for some checks, knowledge checks. Let's start with the first one, and let me make sure I don't show the answer. So let's go with this one. So pie charts work best when um, A, B, C, or D. So a bar chart cannot be used. The number of categories is small, the number of categories is large, comparing the magnitude of the categories. So I'll give you, let's say, 45 seconds for that one. A few more seconds. All right, so let's see those answers. So the chat says B and D. So let's see. So B, the number of categories is small. Yes. So if you have a pie chart, let me do this. So if you have a pie chart, ideally you have a small number of categories, because if you have too many categories, then you start having these very slim slices that are hard to visualize. So this one is correct. I saw a lot of people saying D. So let's say D. Comparing the magnitude of the categories. I would say that one is correct too, because you're looking at the relative frequencies. However, that being said, I think on Codio, this one is the correct answer. So just mark B. But yeah, I can see why you're comparing how big one category is to the other one. So I agree with you guys. Some people might fight me on C if the number of categories is large. Most people don't like putting a lot of categories on pie charts. So for that reason, I would say this one is wrong. But if you feel like it's right, I respect it. And then A is objectively wrong, because you can use a pie chart and a bar chart for the same kind of data. So that one is not relevant. All right. Awesome. So let's go with the next one. Oh yeah, and make sure that in Codio the answers, depending on how you refresh the page, they might be in a different order. So don't just blindly click on B. Make sure it's the one that says this one. All right, let's go with the next one. A relative frequency is a percent of the total. Is that true or is that false? Yeah, it is true. So again, quick recap. Absolute frequency asks the question how many, so you should have a number. Relative frequency asks how often compared to the total. So you would have a percent, that same percentage, you can represent it as a fraction or as a decimal. So yes, the answer is true. Let's go with the next one. Bar charts can only show absolute numbers, not frequencies. So the answer is yes, fake news. It's false because a bar chart, you could have a bar chart that says here, for example, 200 and 100. What is that? That's the absolute frequency. The absolute frequency. But you could also have a relative frequency because you could say, okay, this is like 50, what is this? 2/3 of the data, and this is 1/3 of the data. So that will be the relative frequency. So you can show however you want to display it. So yes. All right, cool. So let me know if there's any questions regarding anything we did today. Let me see them in the chat. But just to do a quick recap of what we did today, we were practicing those data literacy skills, how to think, translate, write, and read data. And specifically, we did a deep dive on tables, bar charts, and pie charts. This is an introduction to some of the things you're going to be doing next week in Excel. At some point, you're going to be doing a kind of like a dashboard on Excel, and then we'll start doing dashboards in actual dashboarding tools. So was a nice introduction for those topics. So some things to keep in mind. To read a table, like I said last time, it's kind of like a battleship. You just locate the column and the row that you need, and you find the information that you need. It seems kind of silly when we were doing it here, but once you start writing functions, so for example, next week, if I'm not mistaken, with SWOT, you're gonna learn index and match functions. So you have to keep track of which column and which row is it that you're referencing, and you have to write these formulas. So you're going to be doing what we did today, but in Excel. And it's going to feel harder, but now you have the foundations. And whenever it gets harder, think about what we did today, because you can always ground it back to it's a battleship game. We're finding that specific cell. Absolute frequencies are counts, and relative frequencies are percentages. Uh, so if you want to remember it with one sentence, that's the sentence. Bar heights in a bar chart are proportional to their frequencies. So you can say, you can quickly get a big picture of what's going on by looking at the bar chart. Y-axis should start at 0 unless there's a very good reason for not doing so. And thank you, Rob, for that example with the Fahrenheit. Pie charts can show the same information as bar charts, but if you have too many categories, maybe go for the bar chart. If you have few categories and you do want to emphasize the relative frequency, then go for the pie chart. And on Codio, you can click here. There's like a document summarizing everything we did here today. So let me check the chat, see if there's questions. I don't see any questions.